Hey guys, welcome back to the next video. In this video, we are going to work with all the other commands. This is going to be the part two of the previous video. Now, in this video, we're going to go with this command next. So once we understood the nodes, like whether the nodes, how many nodes we have set it up, we need to understand the important, operators which we have. That's called a cluster operator. Now, cluster operators are the main platform components that manages and reports the health of the cluster. Now, if you notice on the console, you see these datas over here, right? So these talks about multiple components of your cluster and saying that what state it is in. So likewise, you have something called cluster operators over here. So now cluster operators are the COs over here, which talks about the availability of the cluster, like each component inside a cluster. As you know, OpenShift or Kubernetes, for that matter, is an assembly of multiple components which is installed separately and running as a pod inside the master node and some in the worker node. Okay. Now, what Kubernetes does is like it basically sends out a ping to each of these components and make sure that particular component is available. So when you are updating a specific object, when you're updating a specific cluster operator for that example, you will see that the availability goes to false state and then the progress goes to true state and then degraded goes to true state because when your operator is not available, the particular item will be going on the degraded state, and then once the completion of the update, then it comes back to true state, and then this goes to false state. Now, do remember that cluster update is again part of this training, so we will talk about that later point of time. But this is what you need to think about when you talk about operators or to check whether your cluster is available or not. Okay, so this is a you can type OC get cluster operators. So that's another option of typing it, which will get the same output. And CO is on the other hand is a smaller and faster way of accessing the cluster operator. Now, this is basically the first command which we have out here. And then here are the pods -a. So this what this command does is basically gets the pod information across all namespaces. Now, I'm going to tell you a small item. Okay, so when you have the containers, like for example, we'll take Docker. Now, when you deploy a container into Docker, in our scenario, it's cryo, so that's the container we are using. But if you deploy anything on a Docker, for example, you will be deploying, for example, an app A, for example. Now, when you deploy this app A on Docker container, you're going to have this app A created or app A deployed, okay, where you have the image for the app A and stuff like that. But if I want to deploy the app A for production, you have to deploy it in the same name. You will not be able to do so because you already have an app A running. So what you had to do is like you have to stop the app A and then say like app A dev and then create a deployment. And then you have to create app A production and then you have to create a deployment. This creates a lot of confusion. So that's why Kubernetes, when you have this orchestrator, it came up with a concept called namespaces. Now, namespaces are basically individual component or a virtual configuration which can have multiple pods under it. So pod can have multiple containers under it. So which means that these individual pods can be accumulated into one namespace. For example, you can create a namespace called development, and then you deploy all the applications you want to deploy on development inside that. And then you can use that namespace to be part of your URL as well. And then you can say like you can combine that with a namespace and you can create a URL when you're deploying a route or a service. Now you can create another namespace for production, and in that production namespace, you can deploy all those stuff. all which is related, the application related to production. So you can have the same name of the deployment, or the pod name can be the same, or the deployment name can be the same, which is already reoccurred on the development namespace. So there will be no connection between a development namespace and a production namespace, even though it has the same name of your pod. So this, to avoid this problem, we overcome the problem which we had on the container by creating a namespace. As I said, namespace will be integrated when you deploy a service or something, so that your URL looks different based on the namespaces you have. So that is also gives you a specific advantage, and it will not override your pod name on your URL as well, because there will be always a namespace right after the pod name, so that it can differentiate at the URL level as well. So that's where namespaces were created. So when you use -a option, it's going to display all namespaces. So you see this cluster. So you see these 131 pods. Now, what are these 131 pods? These are the default pods which is needed for your cluster to work. So these are 121 pods, 131 pods and 4 error. These pods are basically hosting your cluster operators. That's a previous command we have seen, cluster operators. So these are the ones which is actually hosting it. So you will see relevance in the pod name and the operator name, so that it can be related to each other. So you see this one output of this. Now you can see the relevance over here. So for, let's take for example, network metrics. Let's take for example Prometheus. Let's take for a metric server. Let's take for example machine configuration, and then cluster autoscaler, cluster bare metal. You see that these are some familiar names which you would have seen. So there's a lot of them, right? So you can see that service CA, we saw it there, down there. Then we saw machine configurations, and then we saw bare metal, cluster operators. Likewise, the console itself is an operator. So the console which you're currently working on, this is an operator. So this, if this is an operator, then there must be a pod running to it. So if you just search for the grep of console, you're gonna get console. All right, so console operator, right? You see that? So all these operators actually run as a pod. So these are pods which runs on different namespaces. So you can see the namespace over here. So it's running on this namespace called open-multis, and then you have the OpenShift-network operator. So you have different namespaces. But by default, when you ignore this and you type enter, it basically gives you no results, because you have not created any pods on the default namespace. So when you are creating a pod, when you're creating a deployment, when you're creating a service without specifying a namespace, it goes and creates in the default namespace. That's a namespace which you have out there. Okay, so it's gonna give you the list of all the things under that namespace. But if you want to specify a namespace and you want to see output on that specific namespace, you can give -n, and then you can specify the namespace. So the only pod which is running under this namespace is this one. Makes sense, right? So this enables you to look at the namespaces in different areas. Okay, so like pods, you have so many other configurations in OpenShift which you can use. So now let's go to the next command. OpenShift let get cluster version. So this basically will give you the cluster version over here. The main cluster version is 4.21.10. So if you look at the relevance on your OC, on your this thing, it is almost be the same, because this is basically tells you the cluster version as in all the operators which you have in the cluster, and that basically tells you the cluster version over here. When you are doing the cluster update, you will see the progression over here as true and this available as false, and you will see all the operators out there will be updating one by one. So you will be looking at that when you do that. So get cluster operators. So you're gonna get a similar output what you saw earlier, and that's basically the co command output, the same thing. And then get machines -a. So how we work with this nodes is basically having them configured as a machine. So when you run this command, get nodes, you can see this servers, right? The servers is where the machines are configured. So when you do this command output, machines-a, you can see that there are two machines running, matching the number of nodes which you have out there. So basically, this means that one machine is configured as master, another one is configured as worker. Now you can scale up and down the machines according to your requirement. There are commands which I will tell you later. And remember, I told you that we can bring down the worker machine, right? So using this mission API namespace, so using this, we can bring it down to 0 replication or replicas, or you can make it 3 as in 3 replica. And same way we can make the master to spin up 3 more nodes with the with bringing up this replicas on the master machine. As this is all part of a machine, so it becomes so easier to scale up and scale down the machines itself. So which means that new masters can join the cluster immediately, and new worker nodes can join the clusters immediately. You also have a horizontal way of doing this autonomously, which means that based on the workload, you can also scale up machines, both in worker node and as well as in master node. So that's another option which you should know. All right, so you know how to access the password. You know what's the just please correct the command because the path is not correct. So always so look for the paths, and I've also told you how to get the path. So just remember that. So here you can create a project and then you can deploy a new application, which we will do it on the next video. Thank you so much for watching this video. I'll see you on the next one.